Hey everyone, welcome back. Today we are going to discuss an essential concept in system design, load balancing. Load balancing is crucial for achieving high availability, scalability, and fault tolerance in your systems. In this video, we will cover what load balancing is, why it is important, different types of load balancers, and best practices for implementing it effectively. So let's dive in. First, what is load balancing? Load balancing is a process of distributing incoming network traffic across multiple servers to ensure that no single server gets overwhelmed. This helps improve the performance and reliability of your application. Think of load balancing like a traffic cop at a busy intersection. The traffic cop makes sure that cars are evenly directed to available lanes, preventing traffic jams and ensuring a smooth flow of cars. So let's take an example. So let's say that we have, let's just go like that. Let's say that we have a client, okay? Now let's make it better. Let's say that we have a client, okay? And we have a distributed system. We have multiple servers because we have server 1, server 2, and server 3. And let's say we have a client 1 and client, let's just server and client server 3, and we have client 1, client 2, and client 3. In our distributed systems, we need to make sure that, for example, a client 1 is connected with server 1 or server 2 or server 3, and client 2 connected with one of these servers, and client 3 as well. And we want to make sure that no server is overwhelmed with requests. So we want to make sure that the client 1 and client 2 and client 3 all of them doesn't connect it to the same server, and the other server doesn't get any requests, because right now server 1 will be overwhelmed with all of these requests. And this is where the load balancers come into play. So basically, the load balancers, what it does, it just take all the incoming requests from the client and it distributed it to the servers to make sure that no server is overwhelmed with requests and no server is underutilized. Also, if one of the server went down, the load balancer will make health checks to make sure that to check on each server. When the load balancer found a server is down, the load balancer will not send any request to this down server, to the failed server, and it will continue try to distribute all the requests among these two servers. So this is how the load balancer works on high level. Okay, so let's talk about why we use load balancers. First, to improve availability and fault tolerance. High availability is one of the key benefits of load balancing. If one server fails, the load balancer can redirect traffic to other healthy servers, ensuring that your application remains accessible. For instance, in an e-commerce application, load balancing ensures that customers can continue shopping even if one of the back-end servers goes offline. Second, we have scalability. Load balancing enables horizontal scalability. As the number of users grows, you can add more servers behind the load balancer to distribute the increased load effectively. Imagine a video streaming platform like Netflix during peak hours. The platform needs to handle millions of requests. By adding more servers and distributing the load, Netflix can ensure smooth streaming for all users. 3. Better performance. By evenly distributed requests, load balancers help improve response times and prevent any single server from becoming a bottleneck. This results in a better user experience. For example, a social media app can handle high traffic more effectively with load balancing, ensuring that users get fast response times even during traffic spikes. Okay, let's talk about types of load balancer. I would say in your system design interview, you will not be faced that much, but it's important to just know that there is types of load balancers. The first thing that we have the hardware load balancer. Hardware load balancers are physical devices that are used to distribute network traffic. They are often used in enterprise environments where reliability and performance are critical. They are typically found in data centers for mission critical applications. However, they can be expensive and are less flexible compared to software solutions. The second thing, which is software load balancers. Software load balancers are applications that run on servers to distribute traffic. They offer flexibility and can be used in both on premise and cloud environments. Popular software load balancers include Nginx, for example, which are commonly used to distribute HTTP requests across multiple web servers. Next, we have cloud load balancers. Cloud load balancers are managed services provided by cloud providers like AWS, ELB, and Azure Load Balancer, and a Google Cloud Load Balancing. They offer seamless integration with cloud services and scale automatically based on demand. For example, if you're using AWS, you can use Elastic Load Balancing to automatically distribute incoming application traffic across multiple EC2 instances, ensuring optimal performance. Okay, let's talk about the algorithms. In this video, I just will talk on algorithms on high level. We will not get in details on how exactly the algorithm works. I'll create a separate video for each algorithm because I guess it's better to create a separate video for each algorithm to understand how it works and what is the pros and cons for each one. So let's start with the round robin. The round robin algorithm distributes incoming requests sequentially to each server in the pool. It's simple and works well when all servers have similar capacities. Second, we have least connections. Least connections algorithm sends requests to the server that currently has the fewest active connections. This helps balance the load more effectively, especially when some servers are handling more demanding tasks. We have IP hash. IP hash uses the client's IP address to determine which server will handle the request. This helps the session persistence, ensuring that requests from the same client are directed to the same server. Okay, right now we need to talk about some challenges, and the first thing will be the single point of failure. Um, if the load balancer itself fails, it becomes a single point of failure. This can bring down the entire system, which is why it's important to implement redundancy. For instance, having multiple load balancers in active passive or active configurations can help to mitigate this risk. The second thing is to manage the state session. It's how to manage the state session persistence. For applications that requires precision persistence, ensuring that all requests from a user go to the same server can be challenging. This is often solved with sticky sessions or using shared session store like Redis. Imagine a user logged into an online shopping site without session persistence. Their shopping cart data might get lost if subsequent requests are directed to a different server. Okay, let's talk about best practices for load balancing. And the first thing will be use health checks. Implement health checks to ensure that traffic is only directed to servers that are online and functioning properly. Most load balancers can automatically stop sending requests to the server if it fails a health checks. The second thing, distribute traffic evenly. Make sure your load balancing algorithm is distributing traffic evenly to avoid overwhelming any single server, which could lead to degraded performance. The second thing, plan for redundancy. Always plan for the redundancy by using multiple load balancers in different configurations. This helps prevent your load balancer from becoming a single point of failure. So, to wrap up, load balancing is a fundamental technique for building scalable and reliable systems. It helps distribute traffic, improve performance, and ensure high availability. Whether you use hardware, software, or cloud based load balancers, understanding how to implement them effectively is the key to managing large scale applications. If you found this video helpful, be sure to like it, subscribe, and hit the notification bell so you don't miss more content on system design and scaling strategies. And as always, drop your question or experience with load balancing in the comment section below. Thanks for watching, and I will see you in the next one.